So I thought we would start off with a nice, easy section and then kind of build on that from there. So this section is four-sided polygons, and this can be found in 5.4 in your books. This is nothing too difficult. A few definitions. Other than that, nothing hard. No theorems, no postulates to worry about in this section. Now, this is introductory, so what we're going to be doing is building on this, and yes, it's still going to include proofs. Not this one, but we're going to be learning how to prove something is a rectangle or a rhombus or whatever. We'll get into that later, though. For now, we're just going to kind of introduce what they are. So, objectives. You will be able to recognize polygons, understand how polygons are named, recognize convex polygons, recognize diagonals of polygons, identify special types of quadrilaterals. A lot of these you've probably heard of, if not all of them. So some of this is probably going to be a review for most of you. If not, it's not too terribly hard. So just take good notes. All right, so here we've got a bunch of figures. Which are polygons? Which are not? Top three, all are. Okay. These are all examples because of a few things. Okay, notice I'm drawing points on this one here. From one point to another, there must not be intersections. Okay? With three consecutive points, they cannot be collinear, meaning they can't all three be on the same line. Okay? So that's just basically an introduction, and they all form straight segments between 2 points. So that's just the basics of it. So all three of those top ones, notice no 3 points are collinear. Straight segments, we're all good. So what's the problem with these on the bottom? Well, remember I said it has to be a straight segment. It has to consist entirely of segments. This is an arc, not a segment. So it is not a polygon. Okay, ABCDE is not a polygon. Actually, that's ABCDEF, not a polygon. Okay? In a polygon, consecutive sides intersect only at endpoints. Non-consecutive sides do not intersect. Consecutive means, okay, this to here is a consecutive side, are two consecutive sides. Problem is, you have an intersection right here. Okay, so this is not a polygon by itself. Even if you took that out and made that D and E, okay, still not a polygon. Look at the bottom one. Now, PKMO, PKMOR, and POR are all polygons. But PKMO, PRO is not, because a vertex must only belong to exactly two sides. So this here can only belong to two sides. Can't belong to this third one here. Okay? Now I'm not showing that for congruence because those aren't necessarily congruent. I'm just illustrating that you could say that PKMOR, POR could be PKMOR, all polygons, but you can't include all three into one. So as it stands, not a polygon. All right. So, are these polygons or not? Well, SVTY is a polygon, but SVTXY is not, because consecutive sides must be non-collinear. So we can't say SVTXY because TX and Y are all collinear, and they can't be. They have to be non-collinear to be a polygon. PLAN, why is that not a polygon? Well, we've got this missing piece here, and a point must be a vertex for exactly two segments. So P is only a vertex for PL, or actually it's an endpoint. It's not a vertex for anything, neither is N. So that can't be a polygon. Now when we name polygons, we can pick any point, any vertex. So like I can say A, and I can go counterclockwise and call that A, B, C, D, E, F. Or you can go clockwise and call it A, F, E, D, C, B. Okay, that's okay. Not okay would be A, D, B, C. I'm running out of room apparently. So let's do this. A, D, B, C, E, F. No good. D, E, F, C, B, A. No good. Because look, D, E, F starts off fine, but then we jump down to here. Okay, you can't do that. Okay, a convex polygon. Most of the polygons that you encounter in this class are going to be convex. Now, a convex polygon is a polygon in which each interior angle has a measure of less than 180. This polygon here, it is a polygon because no 3 points are collinear. Each point forms one vertex. Okay, but this would be a non-convex polygon because this angle here greater than 180. So it doesn't have to be a convex polygon to be a polygon, but most of the ones that you encounter will be. Okay. Now, diagonals of a polygon, I've gone ahead and put them in. Take them out for a second. A diagonal of a polygon is any segment that connects two non-consecutive or non-adjacent vertices of the polygon. So in other words, drawing a line from here to here, that's a side. That's not a diagonal. Okay, diagonal goes from a vertex to anywhere, any other vertex, as long as it doesn't follow along a side. So like here, we could go to this one and we can go to this one. We can't go to this because that creates a side. We can't go to that because that creates a side. So diagonals go from one vertex to another as long as it doesn't follow along a side. Quadrilateral. A quadrilateral describes any four-sided polygons. We're going to be dealing a lot with these. There's a number of special quadrilaterals. Okay. Now, what I want to get into is next section is going to be about proving quadrilaterals. So yes, there might be some theorems and other things involved, but for now we're just going to learn about the different types. So first up, we have these. The first one, it's called a parallelogram because opposite sides are parallel. That's all that needs to happen for it to be a parallelogram. The opposite sides have to be parallel. Okay, a rectangle is a parallelogram, so that means that opposite sides are parallel. But then it also has to have right angles. Okay? A rhombus is a parallelogram, which means opposite sides are parallel. And it has at least two congruent consecutive sides. So that would mean that this side would be congruent to this side. Okay? And that would make it a rhombus. Okay, it doesn't say anything about all four sides having to be, but you get the picture. So a rhombus is a parallelogram with at least two congruent sides. A square is a parallelogram that is a rhombus and a rectangle. So parallelogram, opposite sides parallel, right? Square or rectangle, right angles. Rhombus, at least two consecutive congruent sides. So that and that. And as we know, that also means that this and this are congruent with a square. But again, we'll get into the properties and proving them in the next section. Right now, I'm just kind of introducing you to it. And here are the last three. This is a trapezoid. It's a quadrilateral. Okay. That means we got exactly one pair of parallel sides. So that can't have any more than that. Just one pair of parallel sides. And these are called the base. Both of them. Okay, the two parallel sides are called the base of the trapezoid. That's important to know. And the next one is an isosceles trapezoid. That's a trapezoid in which the non-parallel sides, so if these are parallel, these are the bases, the legs of an isosceles trapezoid are congruent, like an isosceles triangle. An isosceles triangle has at least two congruent sides, so does an isosceles trapezoid. And a kite is a quadrilateral in which disjoint pairs of consecutive sides are congruent. So all that means is that a pair of sides, consecutive sides, so they follow each other, are congruent. That's all. This one follows this one. Okay, it doesn't necessarily have to be the same. You know, all four sides don't have to be congruent, but the two pairs have to be. And